Yes. So, hello and welcome everybody to the Starlight Room. Today's session we have Moet with Industrial Metaverse for Omniverse. I'll leave you the ground and good luck.
All right. Thank you, JP, and good to be here, guys. Let me share my screen and we can then kick off with the session today.
And I'll be talking about the industrial metaverse with Omniverse today. So start off with a bit of a background about myself. So I'm an XR delivery manager at Accenture UK. Accenture is a global consultancy firm that provides services to clients all across the world in multiple regions. And at Accenture, I'm acting as a technology innovation and strategy development manager, which means I get to work with a lot of innovative and cutting edge projects. And one of them is NVIDIA's Omniverse. I'm also acting as the Omniverse offering global lead at MCBG, which is our Metaverse department. And for Omniverse, I get to develop capabilities and software assets which help us deliver cutting edge Metaverse industrial experiences to clients all across the globe. And previous to Accenture, I've got about 13 years of total professional experiences in software development as well as delivering software products to clients in the North America, European, Australian, and Asian regions. So my core focus areas have been around 3D digital twins, extended reality, IoT, geospatial development, and building information management systems. And throughout my career, I've delivered over 500 plus smart building 3D experiences to all these clients, which includes these experiences. So the Accenture MCBG Group, or the Metaverse Continuum Business Group, is a group of professionals at Accenture which have been working on spatial computing, blockchain, and extended reality projects for the past 14 plus years. In total, we've delivered over 820 projects to customers across different regions. And we've got presence in 125 offices and studios all across the world. And these are all strategically placed in different continents, just so that we can very easily and nicely work with all the regional clients in that space and then serve their needs at a local level. We've also got a robust ecosystem of vendors and partners with whom we develop metaverse experiences, just so that we can build on top of the shoulders of giants. And we've also developed an internal metaverse product for Accenture, which helps us onboard new employees into the Accenture family using cutting-edge immersive experiences and virtual reality applications. So, a bit about the industrial metaverse, and we've got a point of view on the industrial metaverse. We feel that the metaverse can bring a fundamental transformation to the industry at large. And that means affecting the experiences, affecting revenues and bottom lines, and governance models for these organizations. So our research has shown that over 5 trillion worth of value can be generated by the metaverse in the next decade or so. And out of that, 500 plus billion can be generated in the next 6 to 7 years just in the industrial metaverse sector. And of course, there's a lot of developments happening in this space. It's a very hot space where lots of companies are investing into. And we've seen in the past year or so, there's lots of hardware products coming up as well, which is, of course, improving the experience and reducing the cost and the barrier to entry to this technology as well. What we've also seen is that the industrial metaverse at large has also the potential to reimagine the companies and their products of today. And we've identified these seven core pillars where this reimagining can happen. The first and foremost is the end customer experience. This is where the immersiveness of spatial computing and extended reality can come in and provide much more intuitive product experiences to your end customers. The kind of products and experiences that are made can also be enhanced by digital augmentations on the physical space by spatial computing and XR. And not only that, the process of creating that product can also be very nicely improved. And that means improving the manufacturing process, making it more efficient, rapidly designing, and the uses of generative AI in enabling creative sector to scale up their productivity. That plays a big role in this as well. Technologies like blockchain and Web3 also come into play in this. And this is when we see a lot of innovation happening in the supply chain and financial payment sector. And this all comes because of the transparency of these technologies, as well as the scalability in improving the processes, cash management, and financial workflows of different organizations. And lastly, what we're also seeing is that internally, all of these companies are also engaging in metaverse experiences to improve the productivity and the day-to-day routines of their employees. And this means creating experiences such as the one Accenture has created for their employees to train them up and to welcome them to the corporation's culture as well as the rules and regulations in them. And of course, the enterprise management of corporations, which includes the data management, your building and space management, as well as collaboration and other workflows that employees have within their enterprise, are also getting affected and improved by the industrial metaverse technology. So now let's talk a bit about what Omniverse is. And a lot of people get confused between the metaverse and Omniverse. So as we all know, the metaverse is a highly immersive 3D experience for end users to consume. Whereas on the other hand, Omniverse is a 3D development platform built by NVIDIA. It is a highly extensible platform which gives you simulation frameworks and capabilities in a real-time collaboration and high-fidelity rendering engine. Using Omniverse, creators, designers, 3D modelers, software developers can all come together and work as a single cohesive team to build their 3D experiences. And Omniverse also comes with a set of APIs and developer tools whereby you can extend Omniverse by developing more extensions and applications inside of it, and then connecting it to the outside world by using the Connect framework. Omniverse is built on the USD file format, which is a way of representing 3D assets and scenes, originally invented by Pixar but now fast becoming an industry standard. So Omniverse itself is built off a multitude of extensions which combine together to become an end user application that your developers or Omniverse users can then consume. All of the content and data is hosted on the Nucleus server, which all of these applications, as well as third-party ecosystem applications, can consume. By using the Connect SDK, multiple ecosystem applications can be connected into Omniverse, and Omniverse can act as a single source of truth, integrating data from all of these applications in different domains into one place. And in terms of the rendering output, Omniverse can render and create experiences and publish them on workstations, PCs, mobile devices, stream them onto your web browser, and then create VR and AR experiences out of the same projects. And all of this is done by the developer tools that Omniverse provides, which are the various SDKs and an internal development app to extend the platform by creating new extensions and connecting it to the outside world. And this is all built on top of the Python programming language and also enabled by the NVIDIA RTX renderer, which is real-time ray tracing technology built by NVIDIA. In terms of the fundamental capabilities of Omniverse, so these are some of the unique feature sets that we've seen Omniverse contains. And this is what makes Omniverse unique in the sense that you won't find these in any other development platform all at once. So starting off with the photorealistic rendering capabilities, this is all enabled by the RTX engine, which provides 3D game technology and rendering inside of your enterprise and industrial experiences. So this is bringing ray tracing and very cool graphics into your otherwise very boring experiences. Collaboration and content sourcing is another aspect where using Omniverse, multiple team members can collaborate together, and Omniverse can act as the single source of truth content hub. Simulation is also another strong point, when Omniverse comes out of the box with physics simulator, particle simulation, as well as robotics and human behavior simulation frameworks as well. And then Omniverse also has some built-in AI-enabled components which can be readily used. And then its extensible platform also lets you integrate external AI applications into Omniverse as well. And as we all know, you can extend Omniverse, it being an open source platform, by developing more core features on top of it to serve your needs. And using the Connect SDK, you can connect to a third-party ecosystem of applications, creating a truly robust platform which can enhance your capabilities in 3D metaverse application creation. And these are some of the applications which Omniverse is compatible with, and this is a list that is always growing. And as we can see, there's lots of application domains which are compatible with Omniverse. So starting with 3D content production, including apps like 3ds Max or Maya. Then we've got material design applications. We've got industrial and manufacturing applications such as Technomatics, Creo, visual components, which can very nicely integrate into Omniverse. Geospatial applications, game engines, and simulation are also some other domains where we've seen a lot of applications that are becoming compatible with the Omniverse ecosystem. And the good thing about this is that your team members can work on in these specialist applications and then bring Omniverse as a single hub where the final experience is being built and rendered. We've also identified some core use cases and core industries where Omniverse can really nicely fit in. And all of these are related to some hardcore industrial use cases that we have been already developing at Accenture. So Omniverse has been a good revelation for us, whereby we are now able to create even more immersive and even more efficient experiences for our clients. And these include use cases across automotive, architecture, engineering and construction, industrial manufacturing, aerospace and defense industries, which all have a lot to do around industrial simulation, product design, and collaboration. We've also seen a lot of use cases around smart cities, and this is all around geospatial data integration, and of course, a lot around autonomous robotics as well. And this has a lot to do with AI and ML. And then there's also some other verticals, such as scientific research, and this is where data modeling plays a big part. And then we've got media and entertainment as well. Omniverse being a really nice renderer, you can do a lot of video production inside of Omniverse as well and use it as your workflow to integrate different data sources into one place. So now let's get to the good part, and this is where I'll show you all of the stuff that we built on top of Omniverse. And first and foremost is the Microsoft Teams Live Share plugin. So this brings the real-time interaction of a fully functional instance of Omniverse powered by the cloud inside the familiar interface of Microsoft Teams. What this does, it gives voice, video, and chat-based collaboration aspects to the Omniverse platform. And using this, multiple stakeholders can come together, add comments and annotations to 3D scenes, and review Metaverse projects in a Microsoft Teams call, just like they would be reviewing any other project during their online calls together. And of course, this brings the photorealism, the highly detailed rendering of Omniverse powered by the cloud and pixel streamed into Microsoft Teams in a cohesive experience as well. So let's see the quick demo of that.
At Accenture, we want to shorten the time between decision making, action, and feedback, both for our teams and clients. To make meetings a place where real work happens, we're harnessing the power of NVIDIA Omniverse, a platform for building and operating industrial metaverse applications via the accessibility and ease of Microsoft collaboration tools. It's still early days, but we want to share what we've been working on. So here we are in a meeting with two of our designers. Hi, Kennedy. Hi, Nat.
Hello.
Hey, everybody.
So let's imagine we're in a collaborative design session, working with a client to build a digital twin of their warehouse. But I don't have Omniverse on my local machine. So while I could ask Nat or Kennedy to share their screens, we can instead connect to Omniverse running in the cloud as a direct integration with Microsoft Teams. Through the Omniverse Teams app, we leverage NVIDIA OVX servers in the cloud, so each of us can view and edit our single source of truth warehouse model right here in real time. Connected to Omniverse Presenter mode, we can each independently move around the warehouse as we like. So I see some annotations here from a previous team.
Yeah, Emma, it looks like they're asking for an additional station. I'll add that now.
I can also switch into composing mode and work alongside Kennedy in real time. Kennedy, let's put the additional station over here.
Ooh, I like that. Give me a second. I'll add the rest of the conveyor belt track.
So while Kennedy is working here, I can move independently to work with Nat. Nat, are there any structural impacts we need to think about?
I've been watching. It looks like that new station may impede our fire escape. I'm going to move that door right over here.
We've gotten a lot done on this call, but we've also got other stakeholders to involve. So I'm going to add a note for our other work streams. And since this is all connected to Teams, in the future, those annotations could become tasks or emails or calendar invites. All right, thanks for your help, Nat and Kennedy.
See ya.
That was just a quick demonstration of where we are today, but we're excited to continue working with NVIDIA and Microsoft to bring 3D collaboration to everyone.
So hopefully this gives you a good idea of what this application can do, and a lot of clients are interested in implementing this on their on-site facilities as well. So the next experience I've got is a geospatial experience of Accenture's Helsinki office, a digital twin that we created using 3ds Max and Omniverse USD Composer-like workflow. So using this workflow, our 3D artist was able to collaborate with other team members to build a singing environment in real time. We were able to fuse data from multiple sources, including Matterport, and now we're using this as an accelerator to create subsequent indoor experiences, including robotics, fire simulation, people simulation, and sunlight simulation inside of the same digital environment. So let's see a quick demo of this. So as you can see on the left side, we've got our 3D artist creating the layout as well as 3D models in 3ds Max, whereas on the right side, we've got Omniverse connected in live workflow mode. And now once everything is in Omniverse, we can use photorealistic textures and lighting effects. And once the environment has all been dressed up, we can use a real-time sunlight simulation extension to simulate lighting conditions inside of the office. And these are some of the photorealistic renders we've taken of the place. And believe me, it looks better than the real world location itself. So what we've done is that we've integrated this office experience inside of a city geospatial digital twin as well. So after building this office building, we decided to build the entire city. And what we've done in this case is integrated with CCM, which is a mapping platform integrated with Google Maps 3D tiles data to create a 3D experience of the entire city. And in this particular experience, we are also able to fuse data from multiple geographic information system sources, which include, of course, Google itself. Then we've got OSM, Matterport, Zone, as well as CTZML data, all combined in a single experience. And again, what we've also been able to do is integrate our office environment into the city environment as well in a very seamless way. And we're also using this city environment as an accelerator for subsequent geospatial experiences, again around different simulation aspects such as massive crowd simulation, command and control centers, smart cities, and space observation. And now that you can see in this case, we've now gone into the building and we can see the full indoor experience of our office in here as well. And this gives you the entire control of Omniverse, whereby you can create your own layouts and other experiences inside of this office environment as well. And now this is showing one of the other rooms, which has some really nice lighting in there. And now we'll go into the kitchen area as well. And you can see how dynamic the lighting and the photorealistic rendering is there. And now we've just popped out again. So using Omniverse as a cohesive platform, we're able to build these macro to micro and then micro to macro use cases, all in the domain of geospatial experiences and technologies. So the next application of Omniverse I want to show you guys is again built on the previous geospatial experience we saw. And in this case, what we're doing is simulating clouds inside of a city environment. So really what this shows is us building a Omniverse extension that connects with SimSpace Viewer, which is an AWS service, and it lets us do complex simulations of virtual worlds based on a grid partition. So in this case, we can define an area where we want the simulation to run and then distribute it into various partitions. And in this case, each partition will run on its own EC2 server, and we can define a unique logic behind the simulation of that particular partition as well. Inside of Omniverse, what we've done is that we built a custom extension that lets us give these starting and ending waypoints, and that is where the simulation can start and end towards. We've also got the option to configure different things like the number of crowd entities we want, the speed, the position as well. And in this case, you can now see the various crowds that have formed across in the city environment, moving towards a single destination. All this is powered by the extensibility of Omniverse. And as you can see, this in itself can simulate over 100,000 entities in a single experience running on a very normal computer system. So this shows you the power of Omniverse in terms of rendering and integrating with third-party simulation softwares. And in this case, it's AWS Instance Viewer. And we've got another view of the entire experience as well. And this is now running one of SimSpace Viewer's Unity application in tandem with Omniverse. And this is going to show us the same simulation running across the two applications in sync together. So now we can see a crowd that has formed within the city square is now going to move across the city between the lanes and onto a particular destination. And of course, the good thing is that you can use the full 3D environment, your own camera angles, and your own storylines to simulate and inspect all of this crowd behavior. And what we've really seen is that this is a really important use case wherever we need to simulate human behavior. And this comes in handy in emergency situations, such as natural disasters or fire emergencies in a city environment, where you want to see how humans or how entities would behave in that particular environment and how would they move from one area to the other and how would they interact with each other. So these are very valid use cases that we've seen around in the industry and seen a lot of interest around as well. So now let's see a few applications of industrial simulation and manufacturing processes inside the Omniverse. So in this case, what we've done is that we built a 3D digital twin of a manufacturing facility, which was built originally using Siemens Technomatic software. And what it does is that it gives you the full power of a simulation application integrated with Omniverse. In this case, we're showing the simulation and the 3D digital twin environment inside of Omniverse. And this shows you the high quality and level of detail that you can add. As you can see, even the labels on the wiring itself as well inside of this industry facility. And as we extend outwards, we can see a full conveyor belt system that was developed inside of Siemens Technomatics and simulating side by side on the left side showing Omniverse and on the right side showing the simulation happening in Technomatics. And as you can see, this is all real-time collaboration happening across an external application inside of Omniverse. And in Omniverse, you get the full environment in full photorealism and immersiveness that you would not otherwise get in the source simulation software itself. So what we've really done in this case is that we've also built a safety training experience and an onboarding experience for new manufacturing workers and industry facility personnel. So in this case, what they can do is run through the entire process in a way that they can confirm what kind of safety gear they need, and also we can showcase some of the danger regions which they do not need to be around. And again, they can see all of this in VR and experience the entire environment in virtual reality in a way that they can get trained and upskilled in a very intuitive fashion. So in the next video, I can show you how this same environment would appear in a VR mode as well. And on the right side, again, we've got Technomatics, where on the left side, we've got Omniverse connected to Vario XR3 headset. And whereas in using that headset, the user can also interact with the environment, not just observe it. This showcases the immersiveness of the platform as well, whereby in a traditional software, you'd just be able to run the simulation, but using Omniverse, you can actually experience it firsthand. And this gives and promotes the intuitiveness, and the learning capability is also enhanced in this case. So using the controllers, you can also interact with the environment in this case, and you can also rehearse or perform again these kind of behaviors where you perhaps could not perform in the real world environment. So this simulation gives you a safe environment where you can rehearse and pre-detect failures or other actions that you would otherwise not perform inside the real world environment. So this next experience we built is all around autonomous mobile robots and using Omniverse ISAC sim-based physics simulation capabilities to optimize the pathfinding capabilities of these autonomous mobile robots. This is very applicable use case in an industrial facility or a warehouse environment. What we've done in this case is that we built a custom Omniverse extension whereby you can configure the different variations that you will need in that environment. You can configure the nav graph, and then you can add some parameters on your robots and figure out the best possible pathways that the robots will then need to follow in order to fulfill those commands. So what you can do is using a simple extension, control and configure this entire simulation experience inside of Omniverse. The first thing you can do is import any environment that you want, and it could be your real world replica digital twin as well in this case, just so that you can run the simulation in your real world as well as a rehearsal to what would be happening in the real world actually. So in this case, what the operator is doing is actually adding some waypoint markers in order to create the navigation graph for the robot in the first place. So this is going to be then connected with a line in a case where you can then create a full nav graph and a pathway where the robot understands it can move. And then using the configuration options, you can create order lists. So consider these that at each waypoint, the robot either needs to pick up some order or some objects, or it needs to drop some objects. And you can also configure parameters such as weight of those objects as well, just so that the robot can then simulate the entire operation in a very cohesive way. And in this case, what happens is that the entire nav graph is then ingested into a nav graph extension inside of Omniverse. And then you can see the different operations that need to happen on different points of the facility as well. And finally, what you can then do is select the robot and then configure its parameters as well. So in this case, you can configure what kind of battery life it would have, what kind of a load bearing capacity would it have, and other such variations, just so that you can rehearse all of that beforehand, rather than having to do this everything on site. So as soon as the simulation starts, what this now does is that it runs the robot on that particular pathway in a very optimized way. And this is all integrated inside of the nav2 stack that we built in order to create optimized pathways for navigable entities. And of course, this is all happening in a 3D environment, so you can immerse yourself in this experience as well if you want to, and observe how the robot would be acting in different camera angles and from different positions inside of that environment itself. In this case, we're reducing the battery capacity of a robot and then understanding what would be the alternate route plan, which will now be configured inside of this environment for that robot. And now we can very easily go through different configurations. So we can add more robots, we can add more capacity to those robots, we can of course increase the capacity of the warehouse environment, and we can run through a lot of other configurations in a way that you could not do that in the real world environment. These would not be feasible in the first place to do so. And now you can do that very easily in this simulation capability that we built inside of Omniverse. And finally, what it also gives you is this very nice reporting capability. So you can take this away and understand what are some of the major occupancy areas that that robot would have, and what is the kind of heat map in terms of the navigation that that robot is making across the entire floor plan. And as the final part of this video, we're also showcasing that it's really easy to change the environment of the entire experience as well. And in this case, we've integrated this into a hospital environment and not a warehouse one. And of course, you can configure it in a way that it fulfills the requirement of that particular experience that you want that robot to simulate into. So again, this is all very cohesively managed inside of the Omniverse platform, all because it can nicely simulate a lot of behaviors as well as connect with external frameworks such as ROS2 in this case. And then we can actually rehearse robots in a very cost effective way and simulate all of the scenarios which you could otherwise could not do inside of a real world. So we also explored particle simulation inside of Omniverse. And in this case, we've implemented a liquid spillage simulation. So what this does is that it exhibits liquid behavior as well as conveyor belt movement and gravity simulation in a single experience. So users can use this experience to simulate the industrial process of having a conveyor belt constantly move one object from one place to the other, and then also understand how would a liquid behave while it's falling, as it can also be configured with different materials, velocity, wind effects, and liquid surface smoothing. And we're now seeing the same liquid being simulated across in a different camera angle. So these kind of simulations can be utilized in industrial settings in order to improve the overall product design of different products, conveyor belt optimization, and layout optimization of the facility, and then also to understand emergency response activities. Like for example, if a liquid would spill inside of a container, how far would it go, and what kind of a cleaning activity would need to be performed. And this is all done by using the native functionality of Omniverse. And this next case, we're running the same simulation, but now this is a pickup simulation of a particular barrel that has some liquid in there. So again, this lets us understand what would be the speed of an autonomous vehicle which is interacting with these warehouse assets inside of a single place. And how quickly would the liquid start to spill, and what would be the emergency response measure that you will need to take in order to minimize the damage that's being done inside of that environment. You can also look at the liquid being simulated in this transparent barrel, so you can see how lifelike and how realistic it looks as it falls over on the ground itself. And not only does Omniverse let you simulate liquid material, but also other particles like fire. And in this case, what we're doing is simulating the spread of fire inside of an interior environment. And such kind of a simulation can be used and also be combined with human behavior elements in order to rehearse fire and safety drills inside of an environment. In this case, we are running a fire in the bottom of a ferry ship, and we are observing how the smoke and the fire particles would then move towards the other floor and outside of that ferry ship itself. So this also helps us design the overall architecture of that vehicle in a way that it promotes safety measures and it follows the safety practices and procedures as well. And you can also then design your ventilation and other emergency vacancies and other kind of emergency events around that. This is a very applicable use case in the fire and safety environment. And of course, any kind of 3D environment you've got, you can simulate fire on top of that and then inspect how the fire will be spreading from one place to the other. So now we've done the same inside of our Helsinki office space as well. So like I mentioned, as we started to build that office space, we've now started to use that as an accelerator to then explore other aspects of Omniverse. And in this case, what we've done is we've done some simulation of fire on top of a sofa furniture. In this case, you can see how the sofa would be burning. And then as you bring it closer to the other furniture item, which is the bigger sofa, you would be able to see how the fire now catches on from the one sofa to the other one. And now as the fire spreads across from the sofa, you can obviously very nicely configure it uh, in a way that you can then provide parameters of the burn intensity, the burn rate, the spread area, smoke generation, and other such configurations that would apply onto that particular material or object. And then you can simulate the same in different lighting conditions as well. And all of this is done in a live collaborative workflow whereby multiple people can come together and simulate the environment from different positions and with different parameters in the same way. The last experience I'd like to show you is a preview of a generative AI experience that we're building using Omniverse. And really what this is a natural language controlled 3D layout generator that we built using Azure's OpenAI APIs and Microsoft Semantic Kernel. So you can start off with a template of a warehouse, which you can select from the custom extension. And then really what you can do is select a particular area inside of that warehouse environment where you want your natural language commands to populate. In this case, we've selected a patch on the floor space of this warehouse model over here. The next thing we then do is give it a prompt. In this case, we've asked the extension to generate raw material boxes inside of this patch area that we've defined. And this query then goes off to OpenAI's API, and we've done some brilliant bit of prompt engineering in order for it to act as a layout generator expert, and it returns us back a list of assets as well as positions, which we can then render inside of the Omniverse environment itself. So we can see that happening as soon as the query gets resolved. We can see a layout of boxes now laid out in front of us. And we're now enhancing this extension in a way that we can scale it up to a larger area. And the way we're doing that is that distributing that areas into different grid cells and then defining what that grid cell can contain. In this case, we are again populating this environment as a warehouse model. And as you can see, using a prompt that we've given it, it will now generate multiple models in different areas of the warehouse itself. So really these kind of experiences simplify the process of creating 3D scenes and environments inside of your metaverse experiences. And even without having professional experience with a professional software, you can just use your natural language words or sentences to create these 3D scenes and layouts. And we can also connect this extension to external asset libraries and expand the list of objects and materials and styles. We've done this specifically for warehouses, but you can imagine we can do this for any kind of environment. So this marks the end of the session, and I hope you found it all informative and useful to attend. I hope this also helps you understand how Omniverse can come in and create these industrial metaverse experiences that bring value to the companies of today and to the industries of tomorrow. If you'd like to carry on this conversation with me, feel free to get in touch with me on LinkedIn or shoot an email to my email address. Thank you very much and hope you all have a good day.
Whoa, it was a very nice talk, Moed. Very interesting. I never heard about the Omniverse, but actually it's amazing what it does. Like so far, there's no questions on the comments, but I have
No
a few
worries.
questions.
For sure, for
Like
sure.
I started when I was watching your videos, like a lot of things were happening in my head. Like first of all, you were saying, for example, when you replicate the city, when you have the virtual twin of the city to run simulations, to do predictions, and so on and so forth, uh, how can like the real world can affect the the virtual twin? But how come the is it possible that the virtual twin affect the real model? For example, the case of the city.
Yeah, so we've seen some use cases in the construction industry. So
Mm.
what our clients in that industry want from us is a rehearsal environment where they can rehearse how, for example, construction of a new building would affect
Mhm.
the sustainability of that particular area. So what they do is that they rehearse these kind of situations using these digital twins, and then when they figure out the most optimum construction process as well as the most optimum parameters for the buildings that they want to build, they then replicate that into the real world. So to answer your question, in some cases there is an entire process that need to be followed in order for having a digital twin getting replicated into the real world. But in some cases, what we're also doing is using the digital twin as a command and control center. So that means you can have an experience where you can control a real world environment staying inside of a digital twin. So we've done that using VR headsets where what you're seeing sitting in your home is a factory environment, and you're controlling some of the conveyor belts, you're managing some of the robots and some of the processes that are happening. and it's actually connected live to a factory that is in some other continent. And you're able to inspect it, you're able to review it, and you're also able to operate it from a remote location. So the other way around is certainly possible as well, not just one way around. So and the real time, or you mean the how quick or how easy or seamless it is, that really depends on the process itself that you're trying to simulate.
And now that you mentioned how rapid it can be, like I understand that the response this depends on the system and the people that it's behind it. But about how quick, I mean, you at the end you were displaying some simulations on how the sofa was burning. Which processor is running this? Like the Omniverse is from NVIDIA, right? So I may
Yeah.
assume that all all the GPUs are from NVIDIA as well to process, because processing all these particle systems takes a lot of resources. So you need
Yeah.
powerful computers to process them.
Yeah. So as a fundamental hardware requirement to run Omniverse, you need an RTX enabled GPU system. That GPUs, those are available in desktop workstations, those are available in laptops as well. Um, as an alternate to that, you can also run Omniverse in the cloud. So you can spin up a virtual machine in Azure or AWS, give it the profile, which has an RTX GPU renderer, and then you can run Omniverse on the cloud and then stream it to your web browser or to any thin client as well. And that is essentially what we're doing in the case of that Microsoft Teams live share application as well. So that actually spins up a new virtual machine on the cloud, which has Omniverse running, and every attendee in that call can then has their own instance of Omniverse, which they can control and manipulate. So yeah, it is flexible in the way that you can run it on actual hardware or you can run it on virtualized hardware. But yes, there is a limitation where you do need powerful GPUs, specifically RTX-based CPUs to run these. Having said that, what we've seen with this kind of technology is that the hardware really, the cost and the hardware comparison kind of catches up, because the expensive GPU of today, maybe 2 years down the road, is very cheap, right? So we're expecting that in the next few years, this is going to become really accessible as the computing hardware technology also improves.
Yeah. And one last question before we close here. Do you think that working with this kind of technologies like the Omniverse is the trend towards all the industries are moving to migrate all the simulations and all the predictions into the Omniverse, or they will just blend with the technologies that are currently existing?
So that's a good question because Omniverse is relatively a very new platform that has just come up. And there is this educational piece that we're doing with our clients as well to give them the value of what Omniverse can bring into their existing solutions. The nice thing about Omniverse is that it does not need to replace anything or become a master of all things. But what it can do is become the glue whereby you can use it to integrate all of the different applications that you are using and do it in one place. So that kind of a paradigm that Omniverse brings a lot of value to some of our clients. And of course, that is I think the main ethos of this platform as well, to be able to work very nicely together with the ecosystem applications. So for our clients, what really matters is the value that they're getting at the end of the day. Uh, of course, technology is just a means of having an end solution. So as a company and as an organization, what we really work with is the client requirement and then figure out what is the right technology that would fulfill that. And in our case, Omniverse is now fulfilling a lot of use cases in this year and the coming year as well. So we'll see a lot of development happening on this technology. It's still early days, but we foresee a lot of potential, and there is a lot of investment that we're doing inside of Accenture as well to build our competencies, not just in one region, but across multiple continents as well. So we'll pretty much will have development centers with Omniverse capable people ready to deliver to clients.
Yes. So as I said before, the Omniverse is something I didn't knew existed, but actually it's very, very, very cool, very powerful. Uh, I would like to investigate more about it, and I hope the
For sure,
all the viewers are also eager to investigate more about it. So
for sure.
I think we can close here, unless you have something else
Sounds
to
good.
add.
No, not really. Feel free to get in touch with me if you're interested with this topic. There's a lot of potential in the industrial metaverse because that is where the real value is for this technology. Of course, improving your manufacturing, your product creation processes, that brings the real value of metaverse and XR into the real world as well. So, very exciting space, and would be very happy to connect with anybody who is interested in this. And of course, thank you, JP, and really nice having this session today.
No, thank you for sharing.
All right,
So I think we
all
can
right.
close up here. We
Cheers.
just have
All
to
right,
run the session out video. So thank you once again, and see you next time.
all right. Have a nice.